Let's look at some of the problems that are, in different sections here. I'll start with number 9. If you got the sine of theta is 5 over 6, and what they want us to do is sketch the right triangle. So let's go ahead and make a right triangle. Let's just label an angle theta so that we've got something to work with. Use Pythagorean identity to determine the third side of the triangle and find the other 5 trig functions of theta. Well, if you think about SOHCAHTOA, this is the opposite side. You could label this opposite over hypotenuse. I'm just going to put OPP over HYP, even though it's not taking it all. So the opposite of the angle is 5, and the hypotenuse is 6. Because of what we did in number 7, we can see that, we can use this idea, even if there had been a triangle that had been like 10 and 12 on those sides, it would have reduced to the same thing. We would still get the same trig function. So we can go ahead and look at it this way. I'm going to call this is our adjacent side, so I'll just call it A, just to kind of help us remember that's what it is. So let's find the third side. If I draw this triangle, I can see I can use the Pythagorean theorem. A squared plus 5 squared is 25 is equal to 6 squared, which is 36. I'm just going to go ahead and square the numbers. So A squared would, if you subtract the 25 from both sides, would be 11, and so A would be the square root of 11. So that's my adjacent side. They want all the trig functions. The reciprocal function of sine is cosecant, so all I got to do there is flip it and get 6/5. For cosine, I could either, there's a couple ways I can do this. I got the triangle over there, so might as well just go ahead and look over there at the sides. It's adjacent over hypotenuse, so that would be square root of 11 over 6. The reciprocal function of cosine is secant, so if I flip that, it's 6 over square root of 11. Then I'd have to rationalize it by saying square root of 11 over square root of 11. So I get 6 square roots of 11 over 11. And then my last one is tangent. I could find tangent by taking the sine and putting it over the cosine. Or I could do opposite over adjacent, which would be 5 over square root of 11. Let me go ahead and rationalize that by multiplying by square root of 11 over square root of 11. Sorry, this just does not mark the way I'd like for it to. That's an 11 under there. So that becomes 5 square root of 11 over 11. Now if I want the cotangent, I just need to flip the fraction. I'm going to circle it in red. I'm going to flip this fraction so that I don't have to rationalize again. That's square root of 11 over 5. So those are my 6 trig functions. I found my third side. It was square root of 11. And I got all 6 trig functions there.